myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about instruction set architecture. At the end of this video, the student would be able to gain knowledge regarding what is instruction set architecture, how it can interact and act as an interface between software and hardware, what are various varieties of instruction set architectures, and a sample instruction set. And the basic agenda of this video is the introduction, what is instruction set architecture, what are various types of ISA, and what are various design issues regarding ISA, and the sample instruction set. In the computer, there are major two elements are there, that is hardware and software. The hardware deals with the physical components of the computer. The software deals with the programs and the instructions. So computer hardware is collection of several components working together. So in the computer, various components are there, how they are interacted, and what are major essential parts in order to run the program smoothly, and how these components can be integrated, what is the CPU and the peripheral devices that a computer can made up, all comes under the hardware. But the software can deals with the how a program can has to be perform the intended task. So a set of instructions that drives the computer for a stipulated task is called a program. So here the collection of programs generally referred as the software. Majorly there are two categories of software, application software and system software. Application software is the programs can has to be collected for one intended functionality, like the library management, the hospital management, electricity bill generation. So one particular application, the software can be written. But the system software is used to control the internal operations of the computer. So the operating system, compiler, interpreter, linker, loader, all these are examples of the system software. So the software deals with the programs or the instructions, but the hardware deals with the physical equipment. When the user supplied the program, how the necessary hardware can has to be active, and how this program can be interfaced with the hardware, and how the functionality can be provided smoothly to the user. That is the responsibility of the instruction set architecture. So it mainly acts as an interface between the hardware components and the software. What are various layers of abstraction? How the user can supply the program and how it can be interacted with the hardware elements with the help of ISA architecture. At which place the ISA architecture can be incorporated, that can be visualized with the layers of abstraction. So here more internal details could not be provided. Only the important abstraction details can has to be implemented and illustrated with this diagram. Majorly here two types of abstractions are there, software abstraction and hardware abstraction. So here from the instruction set architecture, the top layer of layers are considered as the software abstraction, and the bottom layers are considered as hardware abstractions. When the user is working with an application, he can design the algorithm. So how to solve the steps can has to be written in a proper sequence in order to provide solution for a particular problem. So he can design the algorithm first, and he can select the appropriate programming language in order to write the program based on the algorithm designed. After construction of the program can has to be compiled and it can has to be converted in the machine code, and assembly language programs can take the help of assembler to convert into the machine code. The machine code can be generally easily understood by the hardware components or the computer. So here after changing or converting the high level language or assembly language programs into the machine code, they can interact with the instruction set architecture. Thereby the instruction set architecture, in short we can refer it as ISA, can interact with the hardware component with the micro architecture. So the micro architecture can consist of address sequencing, subroutine calls, and how this instruction can has to be converted into micro instruction. All steps can be carried in the micro architecture. So depending upon this micro architecture, micro instruction, what are the needed hardware in order to execute the program correctly is activated with this micro instruction. So various electronic components generally used in the modular design of the computer are gates, resistor, transistors, all these. Those can work on the principles of physics. So here all these bottom layer comes in the hardware abstraction and the top layer comes with the software abstraction. So here the instruction set architecture ISA can has a provide interface between this software abstraction and the hardware abstraction. So increasing order of abstraction can be from bottom to top. So here the complexity can has to be increased from top to bottom. So the understand of the program software can be easily accomplished by the user, but how this program can has to be placed and interacted with the hardware, he is having less awareness. So the increasing complexity can has to be in the order of bottom to top to bottom. But the abstraction layers of abstraction can be taken place, increasing order of abstraction from bottom to top. These are the various layers, and the instruction set architecture is placed between machine code and micro architecture and can be act as an interface between software and hardware layers. So here consider any application, for example the Netscape navigator, the web browser, and with this the user can supply a task. The task can has to be interacted with the operating system, for example Windows 98, and with the help of, if at all, any programming language or assembly language, with the help of compiler and assembler, it has to be converted into the machine code, which in turn takes as input for the instruction set architecture and gives to the various electronic elements with the micro controlled architecture and with the help of micro instructions. So here processor, memory, IO subsystem, how these organizations we discussed in the earlier videos, and with thereby it has to dispatch the control to the digital design, circuit decisions, and the internal electronic components of the transistors. So this hardware can has to be integrated and activated depending upon the microcontrolled architecture with the help of micro instructions. So here the instruction set architecture plays the major role in order to provide the what is the necessary hardware to accomplish and smoothly executing the software. Now we can define what is instruction set architecture. An instruction set architecture is part of abstract model of a computer. Just now we discussed about the What are the various layers of the abstraction? So ISA is a part of abstract model of the computer that defines how CPU controlled by the software. So ISA act as an interface between hardware and software by specifying both what the processor is capable of doing as well as how it gets done. So here the CPU task has to be instantiated with the micro instructions. So what is the CPU can capable of doing and how it can get done can has to be controlled by the ISA. Not only that, the ISA can describe what is the memory model, what is the instruction format, the types and addressing modes, what are the operand registers, types, and what is data addressing, and instructions, various categories of instructions like the arithmetic instructions in order to perform the arithmetic operations, logical instructions in order to perform the bit manipulation and decision making capacity like and or exclusive or like these operations, and the data transfer operations, move, load, store like instructions, and the flow control instructions, jump, call, like this variety of instructions can be decided in by the instruction set. The popular ISAs that are generally used are two types. They are Risk and Sisk. These are the popular architectures, ISA architectures. Not only that, variety of architectures, ISA architectures are available in the market. The first one is Risk, Reduced Instruction Set Computer. In short, referred it as Risk. The second one is Complex Instruction Set Computer. It is, in short, it is referred as Sisk. Next, Minimal Instruction Set Computer. It is MISC. Next, Very Long Instruction Word, VLIW. Explicitly Parallel Instruction Computer, EPIC. One Instruction Set Computer, OISC. Zero Instruction Set Computer, ZISC. So these are the varieties of instruction set architecture. Apart from popular one are the Risk and Sisk. Now we will describe about what are various features of the Risk and Sisk. The first variety of instruction set architecture is the Risk. Risk stands for Reduced Instruction Set Computer Processor, a microprocessor architecture with a simple collection and highly customized set of instructions. It is built to minimize the instruction execution time by optimizing and limiting the number of instructions. So here the instruction execution time is greatly reduced by introducing data cache. Okay. Now in the architecture we will describe these features. So here it has to build to minimize the instruction execution time and optimizing and limiting the number of instructions in the instruction set. The main idea behind this is to make hardware simpler by using an instruction set composed of a few basic steps. So here it is a reduced instruction set. So minimal number of instructions has to be provided in the instruction set. So generally these instructions can be comprised of loading, evaluating, storing operations, just like load command and store command to load and store the data in the particular registers. So here the instruction execution time can be minimized and optimizing the performance of the computer by using the reduced set of instructions. Now this is the architecture of the Risk. So here it is a hardware control unit. This is the data path and here instruction cache and data cache. So two caches can be implemented. So here what are the frequently accessed instructions can be stored in the instruction cache so that they can be readily available for the hardware control unit for the execution. Data can also be put in the cache. The frequently accessed data can also be put in the data cache so that instruction on which data this instruction is going to be executed, both can be readily available for the hardware control unit so that the instruction execution time can be greatly reduced. So this is the RISC architecture. Now we have to discuss about what are the features of the RISC. So here only one cycle execution time. Why? Because instruction is available in the instruction cache on which this instruction on which data it is operates, data is readily available on the data cache. So one cycle execution time can has to be used in the RISC feature. So for executing each instruction in the computer, the RISC processor requires one clock per cycle. The CPU clock cycle, one cycle can be needed for executing the instruction. At each CPI includes fetch, decode and execute method applied in the computer instruction. So the instruction cycle generally involves the steps like fetch the instruction, decode the instruction and execute the instruction. So the instruction is readily available in the instruction cache. Decoding can be done there itself and the data can be readily available. The operands can be readily available in the data cache. Simply execution of the instruction can be carried out. So here it requires only one clock per cycle. The second feature is pipelining technique. The pipelining technique facilitates the parallel processing. Simultaneously, more than one instruction has to be executed. The pipelining technique used in the RISC processor to execute multiple part of stages of instructions to perform more efficiently. The instruction cycle operations can be done not only a single part, multiple parts or multiple steps of the instruction can be executed simultaneously, thereby facilitating instruction pipelining concept in the RISC processor. Next, the third feature is a large number of registers. So, in order to increase the fast processing mechanism, storage registers on the CPU has to be a great number. So RISC processors are optimized with multiple registers that can be used to store instruction, quickly respond to the computer and minimize the interaction with the computer memory. So fetching of the data has to be minimized so that the data can be readily available within the processor CPUs so that the computational task has to be done quickly. So this feature has to be facilitate a large number of registers, thereby computational power can be increased. The next feature is it supports simple addressing mode, fixed length of instruction for executing the pipeline. So generally the data is readily available on the register. So simple addressing modes can be used in the RISC architecture. So here it uses load and store instruction to access the memory locations. So simple and limited instruction reduced the execution time of the process in a RISC. So the name itself, it is a reduced instruction set computer. So instruction set can has a less number of instructions. With these limited number of instructions only, the task has to be accomplished. So the execution time can has to be greatly reduced, and the performance of the computer can be increased by using the Risk architecture. So these are the various features of the Risk architecture. Now, what are the examples of Risk? The first one is ARM architecture. So, it is the most widely used instruction set architecture, and the instruction set architecture produces largest quantity. So, here also ARM architecture can have a limited number of instructions in order to accomplish the task. Next, second architecture is MIPS architecture. It is a 32-bit or 64-bit instruction set developed by MIPS technologies, and it is generally used for academic study. Next architecture is Open Risk. It is a set of open source instruction set. The next one is Spark. It is an instruction set that has been used in SunOS, Solaris, Open Solaris. So these are the examples of Risk architecture that are available in the market. The second variety of ISA is the Sisk. The Sisk full form is the Complex Instruction Set Computer. It is developed by the Intel Corporation. It has a large collection of complex instructions that ranges from simple to very complex. As the name implies, it is a complex instruction set. So, large number of instructions can be available in the Sisk. So, here simple to very complex instructions can be used, and specialized instructions in the assembly language level and long time to execute the instructions. So, a very large number of instructions are available. So, it requires the instruction execution time can be more. The main idea is that a single instruction will do all loading, evaluating, storing operations. And here, like a multiplication command will do stuff like loading data, evaluating, storing it, hence it's complex. So, in order to perform any operation, for example, consider the multiplication operation. First, we have to load the operands, and then you have to perform the processing with the help of multiplication instruction and storing the results in the destination registers. So this involves all these operations. Both approaches try to increase the CPU performance. The Risk and Sisk are aimed to increase the CPU performance. So here is the Sisk architecture. So here this is the control unit, and here this is the microprogram control unit. Instruction and data path, cache, main memory. So what is the frequently accessed instructions can has to be placed in the cache. So the data can has to be fetched, next decoded, fetch the operand, then execution. These steps can be followed in the Sisk architecture in order to execute an instruction, and these are the steps in the instruction cycle. Now we have to discuss about what are the Sisk features. Complex instruction, hence complex instruction decode. So here decoding operation is also the complex one. Instructions are larger than one word size. Instructions may take more than a single clock cycle to get executed. Why? Because here there is no data cache. The operand has to be fetched. So it has to take more than one clock cycle for execution of the instruction. Next, less number of general purpose registers are available. So the data can has to be loaded into the registers, then the operation or the execution of the instruction can be continued. Complex addressing modes can be needed, and more data types can be available in the Sisk architecture. Now we have to compare the Risk and the Sisk architecture. First, we will look into the examples of the Sisk. So here 8086 is one example of Sisk architecture. So here it is Intel 8086 or the 8088 architectures can be the Sisk architectures. Z architecture is also a IBM 64-bit instruction set architecture. It is also one of the example of the Sisk architecture. Intel 8080 is also the example of the Sisk architecture. Now, based on few parameters, now we have to compare and contrast what is the Risk and Sisk features. So here, the first parameter that is considered is the instruction type. So here in the reduced instruction set computer, it is a simple one, but it is a complex instruction set. So the instruction types can be the complex one. Number of instructions can be a reduced number. Generally, 30 to 40 instructions are present in the instruction set. In the complex instruction set, number of instruction set can be extended. They can be 100 to 200 instructions per instruction set. Next, duration of an instruction. So here, the data cache, instruction cache is available in the Risk. So one cycle can be needed to execute the instruction. But in the Sisk, more than one cycle can be needed for instruction execution. Next, instruction format is fixed, but here variable. Next parameter is instruction execution. So, parallel instruction can be executed. The instruction pipeline can be available in the Risk. But in the Sisk, it is a sequential execution of the instruction. Next, addressing modes can be simple in the Risk, but complex in case of Sisk. Next, instruction accessing the memory. So here, load and store has to be used in the Risk. Almost all from the set we have to use in the Sisk. Next, register set is multiple registers are available here. Only some unique registers can be available. Complexity is in compiler but in CPU. So these are the differences between Risk and Sisk by considering these parameters. Next is, while designing the instruction set architecture, what are the design principles to be followed? So, simplicity favors regularity. So, the instruction size, instruction format specification, data format specification can simplify the hardware. So, simplicity has to be considered during design of the instruction size, instruction format and the data format. Smaller is faster. Few bits to read, move and write. So that the instruction execution takes less number of cycles in order to execute. Next, make the common case fast. So small constants are common, thus immediate fields can be small. Immediately the operands are available so that the execution can be faster. Good design demands compromise. Special formats for important exceptions and jump cases can be considered so that the small constants can be used in order to rectify the infinite loops. What are the design considerations? So these instruction set formats, instruction format, data format can change the state of the memory. So data representation can be considered. And here the instruction format addressing modes can be considered as a major design consideration. Next, the ALU operations. Here, variety of instructions can be used in the instruction set, like arithmetic, logical, shift. All these instructions can has to be designed carefully, which can facilitate the ALU operations. Next, data movement can also be considered here. How the memory referenced instruction, register referenced instructions, IO referenced instructions, and how these data movement can be carried out is the third design consideration. Next one is the control and branching statement can also be considered. What instructions you can do the next, how to update the PC address, and how the comparison or testing can be done. After evaluation of testing, how branching can be done, how to call procedures. All these considerations can be considered during the design of the instruction set architecture. So the instruction set can be the measure in the instruction set architecture. So the instruction set provides the commands to the processor to tell it what it need to do next. So here the user what functionality is required, depending upon that appropriate instruction from the instruction set can be chosen. The instruction set consists of addressing modes, instructions, native data types, registers, memory architecture, interrupts, exception handling, and external I/O. So related to all these, the instruction set has to provide the instructions. An instruction set can be built into the hardware of the processor, and it can be emulated in software using an interpreter. The hardware design is more efficient and faster for running the programs than the emulated version of the software. Now we have to consider a sample instruction set of 8086 instruction set. Here a variety of instructions are provided in the 8086 instruction set in order to facilitate various operations. There are data transfer instructions, arithmetic instructions, logical instructions, bit manipulation instructions, shift instructions, branch and loop instructions. The data transfer instructions generally used to facilitate the data movement between memory and processor registers, as well as from input output also. Next category is arithmetic instructions. The arithmetic instruction facilitates the computational activities like addition, subtraction, multiplication, and division comes under this category. The logical instructions provides the bit manipulation as well as decision making capacity. So here the AND or exclusive OR comes under this category. Next, bit manipulation instructions, shift instructions, branch and loop instructions can be the next varieties of the sample instruction set. One after another we have to discuss in the sample instruction set of 8086. In the data transfer instructions, the first general instructions used is the MOV move. So it is used to copy a byte or word from previous source to the provided destination. And here not only between the memory and the register, the transfer can be take place. Between by using the stack CPU based organizations, two instructions can be generally used. P push to place a word on the top of the stack. Pop is used to get a word from the top of the stack. And swapping of the data between the registers can be taken place with the help of XCHG exchange. So these instructions can facilitate the data transfer operations. So if at all it is a register based instruction set, simply you have to give the mnemonic first like moving the data between the registers MOV R1 comma R2. So in between the what is the content in the register R2 can be moved to the register R1. So in this way, what are the instructions that are available in sample instruction set of 8086 to facilitate the various operations? The first category is the data transfer instructions. Next category is how data transfer can take place between input-output registers. So here in is used to read a byte or word from provided port to take the input from that port in mnemonic can be used, and here to send a byte or word from the accumulator to the provided port out instruction can be used. So these facilitate the data movement between input and output ports. Next variety of instructions are arithmetic instructions. The arithmetic instruction facilitates the computational capacity. So here numerous instructions can be used. The add instruction is used to provide addition. Add C is addition operation along with carry. INC means increment operation. The register specified register content can be incremented by 1. Next, sub is used to facilitate the subtraction operation. Subtract with borrow can be facilitated with SBB. And DEC is decrement operation. The register content can be reduced by 1 with the help of DEC instruction code. Next is MUL to perform the multiplication operation, DIV to perform the division operation. So these are the list of instructions which will facilitate the arithmetic operations. Next category is bit manipulation instructions. So logical operations can has to be performed on the each bit of the registers. Not is used, AND operation, AND logical operation, OR logical operation, XOR logical operation can be used. To perform a test, based on that the flags can has to be activated so that the instruction test can be used to evaluate the conditions. Next category is the shift instructions. There is two types of operations can be performed, that is left shift and right shift operations. So here logical shift operations can be specified with SHL and SAL and SHR, but circular shift operations can be performed with the ROL, rotate left, ROR, rotate right. So these are the 8086 shift instruction set. Next, branch and loop instructions. In order to call a procedure is a small block of code. Whenever it is called, it has to be executed and returned to the main program after its execution is completed. So here the call can be used to call a procedure. Next, return is after completion of execution of the procedure, the return statement return the control again back to the called program. Next is jump. In the jump instruction, two types are there: conditional jump, unconditional jump. Conditional jump means first evaluation of condition can be take place. If the condition is satisfied, then only the transfer of control jump instruction can be executed. And in the second category, unconditional jump, without checking the condition, the jump transfer has to be take place. So here it has to provide to transfer the control to the specified label during the program execution. All these are the varieties of instructions that are available in the sample instruction set of 8086. So here in this video, we have discussed about the what is the instruction set architecture, where it is placed, how it can be act as an interface between software abstraction layer and the hardware abstraction layer, and what are the varieties of instruction set architectures available in the memory, and by considering two popular architectures Risk and Sisk, explaining their features and comparing and contrasting the Risk and Sisk architectures can be carried out. Next, we have concentrating on the what are the design principles and design consideration during the instruction architecture. Next, what is instruction set? By taking 8086 sample instruction set, various categories of instructions like arithmetic, data movement, branching instructions, and logical instructions can be explained in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.